हेलो एवरीवन। आज हम CSIR नेट मैथमेटिक्स के जून 2019 के एक इंटीग्रल इक्वेशन के क्वेश्चन को देखेंगे जो बहुत सिंपल है। जहाँ पर दिया हुआ है कि if y is a solution of the integral equation y of x equals to 0 to x minus t yt dt equals to 1, then इनमें से कौन सा ऑप्शन करेक्ट होगा? Which of the following is true? पूछा है y is bounded but not periodic in R, y is periodic in R, एक इंटीग्रेशन लेस देन इन्फिनिटी है और एक इंटीग्रेशन 1/y(x) लेस देन इन्फिनिटी और इंटीग्रेशन y(x) लेस देन इन्फिनिटी। सो हाउ टू सॉल्व दिस? सबसे पहले हमारा इंटीग्रल इक्वेशन क्या दिया हुआ है हम लिख लेते हैं। दैट इज y(x) इक्वल्स टू 0 to x माइनस टी इंटू वाई टी डी टी इक्वल्स टू 1। Sorry, यहाँ पर y(x) is minus this one, so this is minus. So y(x) minus this equals to 1. So इससे पहले हम सॉल्व कर लेते हैं ताकि हमें y(x) एक फंक्शन के रूप में मिल जाए। That means we will solve this integral equation to get the function y(x). Okay. So what we will do? We will differentiate both sides with respect to x. So d by dx of LHS left hand side is equals to d by dx of right hand side. Right hand side is a constant which is very easy, which is equals to 0. So left hand side को पहले differentiate कर देते हैं with respect to x, that is d by dx of y of x is y dash x minus d by dx of one integral, that is 0 to x minus t y t dt. So जहाँ पर हम Leibniz rule लगाएंगे, Leibniz rule is for derivative of an integral, okay, and RHS is 0. Now next step में हम क्या करेंगे, y dash x as it is. Now Leibniz rule लगाएंगे. What is Leibniz rule? Leibniz rule states that d by dx of an integral, that is 0 to x, equals to d by dx of the upper integral into the value of the value of the term if we put that upper integral. ओके, सो यहाँ पर क्या करेंगे, x का डेरिवेटिव निकालें इनटू x माइनस टी वाई टी डी टी में t के प्लेस में x पुट करेंगे। सिमिलरली प्लस 0 to x डेरिवेटिव ऑफ द inner term with respect to x, that is d by dx of x minus t yt dt. okay, and RHS is as it is 0. सो ये है लिबनिज रूल। सो लिबनिज रूल को लगाए अप्लाई करने से हमें क्या मिला, वाई डैश एक्स माइनस डी बाई डी एक्स ऑफ एक्स इज 1 और ये एक्स माइनस एक्स इज 0। सो होल टर्म क्या हो जाएगा, 0 हो जाएगा। प्लस सेकेंड टर्म क्या हो जाएगा, डेरिवेटिव ऑफ एक्स माइनस टी डी बाई डी एक्स ऑफ एक्स माइनस टी विच इज इक्वल्स टू 1, okay, and yt as it is. So 0 to x into yt dt as it is, because ये term d by dx of x minus t is 1. So yt dt ये ब्रैकेट के अंदर है and that equals to 0. okay, so ये ब्रैकेट के अंदर इसको ब्रैकेट लगाएंगे, this minus 0 plus the previous terms. So इसको ब्रैकेट के बाहर लाएंगे तो क्या होगा, this is 1 as it is, which we have done in the previous step. So it is 0 to x yt dt, okay, equals to 0. अब यहाँ क्या करेंगे, बिकॉज नेक्स्ट स्टेप में भी फिर से हमें डेरिवेटिव विथ रेस्पेक्ट टू एक्स बोथ साइड वी हैव टू अगेन अप्लाई. सो यहाँ पर क्या होगा, डी बाई डी एक्स ऑफ सेकेंड टर्म इज 0 to x yt dt इज इक्वल्स टू 0. डेरिवेटिव ऑफ 0 इज 0. सो नेक्स्ट में क्या होगा, डी बाई डी एक्स ऑफ वाई डैश एक्स इज अगेन वाई डबल डैश एक्स, 2 times डेरिवेटिव ऑफ वाई ऑफ एक्स माइनस फिर से लीबनिज रूल लगाएंगे, दैट मीन्स डेरिवेटिव ऑफ द अपर इंटीग्रल, दैट मीन्स एक्स इंटू वाई ऑफ एक्स प्लस 0 to x derivative of the inner term with respect to x yt dt, which is obviously 0 because yt is a function of t and d by dx is with respect to x. So what we will do, next step will be y double dash x minus derivative x is 1, and first term will be y of x, and second term is obviously it is 0. So we will get this much is equals to 0. So इसको अभी सॉल्व करना है, y डबल डैश x minus y of x, a simple ODE, okay, of second order. So it is d square y minus y is equals to 0, and where what is d? D is nothing but d by dx. It is an operator, d by dx. So d square will be 2 times derivative. So it is d square minus 1 into y is equals to 0. Okay, from which we get d square minus 1 equals to 0. Okay, and from which we get d is equals to plus or minus 1. So after getting d is equals to plus or minus 1, we can write the general solution of y of x as y of x is equals to c1, because d is plus or minus 1, either plus 1 or minus 1. So if it is plus 1, it is c1 e to the power x plus c2 e to the power minus x. Okay, this one will be a general solution of y of x. Now we have to find c1 and c2. Okay, for finding c1 and c2 we must know the initial conditions. Okay, what are the initial conditions so that we can apply to find the constants c1 and c2? So initial conditions can be obtained from the initial equation, integral equation, that is y of x minus 0 to x minus t yt dt equals to 1. If we put x equals to 0 here, what we'll get? Second term will vanish and we'll get y of 0 equals to 1. So directly we can write y of 0 is equals to 1, because if we put 0 in the initial equation, second term will totally vanish, 0 to 0, so it is totally 0. And for second initial condition, we put here x equals 0, we get y dash 0 equals to 0. So y dash 0 is equals to 0. So we get two initial condition which will apply to get the constant c1 and c2. Okay, so now we'll put what is y dash x, because we have to apply y dash 0, for which we need y dash x, which is c1 e to the power x minus c2 e to the power minus x. Okay, so now we can directly apply the initial condition. So we have y of x, again we can write is c1 e to the power x plus c2 e to the power minus x. We apply y of 0 is equals to 1 here, and we get y of 0 which is 1, and c1 e to the power 0 which is 1, and c2 e to the power 0 1. So c1 plus c2 is equals to 1. Similarly, y dash x is equals to c1 e to the power x minus c2 e to the power minus x, and applying y dash 0 is equals to 0, we get 0 is equals to c1 minus c2. So we got two equations and two unknowns c1 and c2, from which we can directly evaluate. We can add the two equation 1 plus 2, we get 2c1 is equals to 1, so c1 is equals to half, and just putting the value of c1 in first equation we get c2 equals to half, because c1 plus c2 equals to 1, so c1 is half, so c2 is 1 minus half, which is half. Directly substitute this c1 and c2 in y of x is equals to what we'll get. C1 is half e to the power x plus c2 is half e to the power minus x. So we can write y of x equals to half e to the power x plus half e to the power minus x. Or we can write, taking common LCM, e to the power x plus e to the power minus x by 2, which is the formula of cos hyperbolic x. Okay, we know that cos hyperbolic x is e to the power x plus e to the power minus x by 2. Now we'll see the options. Options क्या क्या है? First is y is bounded. It is told that y is bounded and but not periodic in R. So directly we can see the sketch of cos hyperbolic s. So cos hyperbolic x कुछ इस तरह दिखता है. So directly we can see it is unbounded. It is not bounded. So first option is incorrect. Second option is periodic, but it is not periodic. Cos hyperbolic x is not periodic. It is incorrect. So 1 and 2 are discarded. Third one we can check that integration करेंगे y of x. What is y of x? Cos hyperbolic x. So y of x का integration with respect to x in real number, is it less than infinity? We can check cos hyperbolic x from minus infinity to infinity. Is sine hyperbolic x from minus infinity to infinity? And which can be said that is equals to infinity, because it is sine hyperbolic infinity minus sine hyperbolic minus infinity, which is not less than infinity. So third is also discarded. Okay, so one option is only left, that is integration of 1 by y of x dx. We have to check, is it less than infinity or equals to infinity. So we can directly check from the formula. Y of x is cos hyperbolic x, and what is cos hx in terms of e to the power x. So we can write cos hx in terms of e to the power x as, because cos hx is e to the power x plus e to the power minus x by 2. So its reciprocal is 2 by e to the power x plus e to the power minus x dx minus infinity to infinity. Just we can substitute something here, that is e to the power minus x is 1 by e to the power x. So just take e to the power x to numerator. So it will be e to the power 2x plus 1 integration with respect to x. So here what we can substitute? We can substitute t is equals to e to the power x. So dt by dx is again e to the power x. The integrand here, what we will get? So first of all, what are the limits of integration we can write? Here, when x is infinity, t is equals to e to the power infinity is again infinity. So x is infinity, then t is infinity. Okay, but when x is minus infinity, so what is t? E to the power minus infinity, and which is 1 by e to the power infinity, which is 0. So when x is minus infinity to infinity, t will be 0 to infinity. So just write 2 e to the power x, because it will get cancelled, and e to the power x whole square, or it is t square. We can write in next step plus 1 dx. In place of dx, we can write dt by e to the power x, which can get cancelled. So dt by e to the power x. So e to the power x, e to the power x get cancelled, and in place of e to the power x, we can write t. So it is either 0 to infinity 2 by t square plus 1, because e to the power x is t. So it is t square plus 1 dt. Now it has been very much simplified. So which can be written as 2 tan inverse t, because integration of 1 by 1 plus t square dt is tan inverse t, and it is from 0 to infinity. So we can write 2 tan inverse infinity minus 2 tan inverse 0. 2 tan inverse 0 is 0, and 2 tan inverse infinity is 2 into pi by 2, because tan inverse infinity is pi by 2. So it will give us pi. So final answer is pi, that is integration of 1 by y of x dfx e dx is pi, and which is obviously less than infinity. So our fourth option is obviously correct. So if you understand the solution, you like, share, and subscribe to the channel for more such updates. Thank you.